there is fundamental unit. All quantities under fundamental has a unit, and that unit that represents the quantities of fundamental are called fundamental units. So looking at all those units, we have the kg per meter cube. Kg is mass, per meter cube is volume. So mass per volume is what? Density. That's how you have to break it down. Then the next one we have is m cube. M cube is what? Is volume. Density here is a what? Is a derived quantity. Volume here is a derived quantity. Do you understand? So you use the derivation of what? From those units. You use the derivation from those units to actually obtain their quantity. Now, we said we've gotten volume, we've gotten density. The third one is what? Newton meter squared. Newton is force. Meter squared is area. Do you understand? So this particular one is definitely the best answer as a fundamental quantity. Then the last option there is what? Your kg, which is your mass. The third question says that which of the following is not correct SI unit? Is not the correct SI unit of the quantity involved. A, we have acceleration. I told you the other time, I said whenever you have the acceleration, you must what? Break it as acceleration. You must break them down. Now, the formula for acceleration we said the other time is what? Meter per second squared. So number one is correct. I mean the first option is correct. That's option A. Option B is momentum. Momentum is what? Momentum is what? Mass dot volume. I mean velocity. Mass times velocity. So that particular unit for momentum is what? Wrong. That's ms. Then the third option there is work, and the SI unit for joule is also, the SI unit for work is also what? Joule. The fourth one is what? Energy. Energy. The SI unit for energy is joule. So that option there for joule being the SI unit, joule being the SI unit of energy. So for you to have watts there, watt is the SI unit of what? Power. So the best answer there is the what? Option D. So that we've answered question 3. Question 4 says that which of this motion could be uniform? Which of this motion could be uniform? Number 1. Now, if you recall, the last time we spoke about the different what types of motion. We said we have the what? Random, we have the circular, we have the transitional, we have the rotatory. So if you look at that question, say which of this motion could be what? Uniform, a uniform motion. Number 1 option there says the A. What I meant by there is A. A says molecular motion, B says circular motion, C says vibratory pendulum, and D says vibrational motion. So which one is uniform? The best option there that is uniform is your molecular motion. Molecular motion. So I think we've answered the 4th question. The 5th question says that which of the following is incorrect? Which of the following is incorrect? That is, which of the what following option is not correct? A. Distance is scalar. Distance is scalar. We mentioned it the other day. We said distance, which is measured in what? Which is measured in what? Length, the normal length, which is your meter or what? Your millimeter. They are all SI units for what? Distance. So definitely distance is scalar. Now, the next option there is displacement is vector. The next option, speed is vector. The last option there says velocity is vector. So the best answer there that is incorrect is your what? Is your displacement. Do you understand? Your displacement is your what? Is your vector. Sorry, your displacement is your what? Scalar quantity. And that option there says displacement is vector. So as you're answering those questions, you need to realize that you have to flip back to what? All what we have done, so that you can super confirm if actually those options are very good as an answer. So I think that's for the number 5. Now number 6. The number 6 question says which of the following equation is correct? Which of the following equation is correct? The other time when we were talking about equations of motion, I made mention that there are 3 basic types of classes of equations of motion. We said we have normal V, which equals U plus what? U plus what? AT. We also said we have the normal what? X equals what? AT plus what? Half AT squared. Sorry, UT plus half AT squared. Now the third one we have the V squared equals U squared plus what? 2AS. These are the 3 major equations of motion. Now if you look at it, they are definitely referring to this first 1. So if you actually look at this, which of them is correct? So definitely the first option is correct. That's option A. Now for number 7. Number 7 says the slope of this displacement time graph is equal to what? The slope of your displacement time graph. What is displacement time graph? Displacement time graph is a graph of displacement. It's a graph of displacement entity. This displacement will be here of your displacement entity against what? Against time. Hope you are seeing it. Displacement time graph is a graph of your what? Displacement entity against your what? Of your time. So the slope, this will be the slope. Displacement here is measured in what? In, let's say, x. So here will be what? Here will be x1, and here will be what? Maybe let's use x0. So at this junction we have your x1, x0. At this junction you have your t1 and your what? T0. So the slope here is now what? Changing what? That's your x1 minus x0 all over what? All over what? T1 minus what? T0. That's delta x over what? Delta t. So x over t, this distance per time is called velocity. It's called velocity. And that's what we call your uniform velocity. It's a uniform velocity. What does the word uniform mean then? The word uniform means, actually there means that it has a what? A stable velocity. A velocity that is not what? That is not shakeable. That's a uniform, a constant velocity. So the best answer there is what? Option E. Question 8 says that define instantaneous speed. Instantaneous speed. Instantaneous speed. What is instantaneous speed? We said instantaneous speed. Speed is just, we said our speed is changing what? Distance over what? Over changing time. Do you understand? So when you become instantaneous, we are looking at what? Small change. That's your small change in your distance over what? A small change in what? In time. That's just why it is being meant by what? Instantaneous. So this instantaneous is just a sharp change in what? When I say fraction, the fraction between your small what? Change in distance and your over your small change in what? In time. Now let's go to the next option there. The next question there under that 8, that's 8b. It says use a graph to explain the following, the meaning of the following bearings. Now in our mathematics, when we say bearing, let's divert a little. When we say bearing is just talking about if this is to be the globe of the planet Earth. Now we know what we call your north pole. Your north pole will definitely be somewhere here, and your south pole is somewhere here. Now we have another pole here, which is your what? Which is your west, and this is your what? East pole. You understand? So in our bearing, we normally make use of what we call your compass. Normally makes use of a compass. Now, what is a compass? A compass is just any device that is actually being used to make you detect the direction at which you are standing. Let's say, for instance, you are in Nigeria. We're in Nigeria, Oyo State. We're in Oyo State, Ibadan, being the capital of what? Of Oyo State. Now, this Ibadan, if you are to have a compass, which is what? Which is with you. Now, this compass will be rotating, will be deflecting towards what? This north pole. That is indicating, showing to you where exactly you are located. If peradventure you are here now, and your compass is with you, by the time you use your compass to locate where your compass will tell you that you are between south and what? East. You understand? That is the angle by which you are. Let's say if this is 80 degrees now. So your compass will tell you that you are on south 80 degrees east. You understand? So, but if you move further, if you want to move further now, we'll be looking at what we call latitude and longitude. But don't let us deviate. All these are just main deviations. So let's go back to our question. The question says, explain these values in what? In bearing. That's not 60 degree east. You look at not 60 degree east. How do you draw that? All this is just what you have to do. Draw your what? Cartesian coordinate or your Cartesian graph. Name them in terms of a pole. This is your north, this is your south, this is your what? East, and this is your what? West. So if they say north 60 degree east, you start from the north and you draw your what angle down. At this junction, you might make use of what we call your protractor. This is what we call protractor. So this your protractor is being calibrated from 0 degrees down to what 180 degrees. So if you put your protractor here, let's say you put it here, you can now measure from here to here. Now this particular thing will give you a what angle 60 degrees. So this will definitely be your position A that you are looking for, which is north 60 degree east. So this is the graphical representation of what this particular question. So if you are asked to look also on graphical representation of south 40 degrees west, what do? Draw your graph, locate your point north south, west east. The question says 40 degree south to west, south to west. So you are starting from your south, measure your 40, draw your broken line down, and this is your point B that you are looking for. So this will be your 40 degree. You have what? Explain south 40 degree west. Now you should be able to do the last one, which is your what? Your 260 degrees. This one is not indicating any particular north or south. If you are not indicated, and if you are not given a particular direction in terms of your north, south, or west pole, what do? You just start from your what? Origin. The major origin of your what? Of your coordinate area is your what? Is your north. Start from your origin. Now if you want to start from your origin, what do? You start from